Hello, everyone, and welcome. My name is Rob Mello, and together with my partner, Lisa Lorenzen, we will be presenting our webinar entitled Beyond COVID-19, Transformation for a Resilient Future. In this webinar, we'll discuss Zscaler's view on how we can leverage the structures deployed under duress as part of COVID-19 and build upon them for a secure, resilient future. We'll discuss how organizations are reconsidering their strategic plans based upon our current circumstances. We'll look at challenges and ambitions and changes to how businesses need to work. We'll then investigate trends that we're seeing in technology and the capabilities we need to utilize for added value. Again, my name is Rob Mello. I'm Head of Strategy and Transformation for Orange Business Services in the Americas. Graciously joined by Lisa Lorenzen. She's Director of Transformation Strategy at Zscaler. And then I have Mark Schlesinger as well. He's our Director and Partner Management at Orange. And he's going to help out with Q&A throughout the session. You can anonymously submit your questions under the questions area on the right-hand side. We'll monitor these questions throughout the presentation, and then we'll also have a chat session as well. So you can actually pose some comments and questions into chat as well. All right, with that, let's get started. My pleasure to hand it over to Lisa.
Thank you. It's great to be with you today. So when we think about the changes that have come about as a result of COVID-19, they're really an acceleration of a digital transformation that started happening long before this pandemic. We've been seeing for years that the internet is really becoming our corporate networks, the new connectivity layer. Cisco puts out a great annual report that has some really interesting internet statistics. And so all the statistics I have here are from that report. And one of them is that in 2016, they were projecting 4.6x growth in traffic on the internet before 2021. So we're midway through that time period, and we're definitely seeing that increase. Also, we're seeing more and more that users are working from anywhere and on any types of devices. By 2023, Cisco projects that there will be 1.4 billion 5G devices. So not only are the devices in our hands getting faster, the connectivity that we use them on is getting faster as well. Parallel, the cloud is really the new destination for applications and services. The public cloud revenue from 2016 to 2021 was projected to grow over 220x. And we're seeing that a lot of that traffic is human-driven, but a lot of it isn't. That servers, Internet of Things, and operational technology are contributing more and more to that traffic flow. So Cisco projects that machine-to-machine traffic will account for 50% of all connected devices by 2023. And the result is that more and more these days, business is taking place off-net. And in a world where the enterprise security model was to establish a perimeter, protect everything inside the perimeter, and assume that everything outside the perimeter was untrusted, we really have to figure out how to apply those principles to this world of cloud and mobility, where users can be connecting from anywhere to resources that can be hosted in multiple locations. What we see is that this is driving a change in architectural approach. I grew up in a world of network security where we had a hard perimeter and a soft interior, the M&M security model. You had a stack of appliances at the edge of the network controlling all outbound traffic, URL filtering, data leak prevention, firewall, IPS, antivirus, sandboxing, and more. And you had that same parallel stack of appliances for inbound traffic, a VPN gateway in a DMZ, scaled up by load balancers, possibly with global server load balancing, possibly with denial of service protection for that inbound listener. So this is really a castle and moat approach to networking. And that approach was really designed for a hub and spoke environment where the data center was the center of gravity and everything else connected into the data center, both for outbound and inbound traffic. The challenge there is that it really doesn't offer the best security. You've got the challenges in scaling those appliances, and you have to replicate your security stacks across multiple locations. The user experience can be challenging as well, because in either direction, you're going through multiple hops to get to what you want. And if you're connecting inbound to resources, you have a single ingress point, which means you have to backhaul to any other resource in any other location. So you've got this hairpinning effect. Also, this is complicated and expensive to build, deploy, and maintain across multiple sites. The next step in this approach was to try to take advantage of the cloud for our enterprise security in the same way that we were taking advantage of the cloud for application delivery, and moving the security functions into a scalable distributed environment. Unfortunately, there are some challenges with just taking a physical appliance and virtualizing it on a cloud provider. You still have the inbound attack surface. You still have the single ingress point with all the problems of backhaul and hairpinning. And if you thought it was difficult to scale and manage a stack of appliances that you do control, you can imagine that that difficulty increases as those appliances are now no longer something that you can reach over and reboot. So it was a good first attempt, but really fundamentally, we were attempting to take a security model that was born in a different environment and apply it in a world that has evolved beyond those points. If you take a step back and design a solution for this world of cloud and mobility, it looks a lot different. If you can put policy and enforcement in the cloud between the user and the application that they're trying to access, then you can provide consistent user experience and unmatched protection, regardless of whether they're going to internet and software as a service resources or accessing private applications in public cloud providers, private tenants, or data center environments. So you can allow direct connectivity. You can allow the user to have access simultaneous to resources in multiple environments, and you can really eliminate the attack surface that's exposed by an inbound listener. So this enables us to take a zero trust model and apply it outside of the original concept of zero trust to this world of cloud and mobility today.
Hey, Lisa, I just wanted to stop you right there because this spawns a question, I guess, right? I'm looking at this, I'm seeing these three different diagrams you have up here. You're talking about a few different architectural approaches. Question really is, IT budgets today have been either paralyzed or drastically cut. How do we actually start to move in this direction to justify these new architectural models and approaches when you have those freeze in budgets or limits in budgets?
Right, that can be extremely tough. You barely have the money to keep the lights on at this point, possibly. How do you then extend that to starting new initiatives? And I think one of the answers is to consider the bigger picture. IT and InfoSec in particular have always been seen as a cost center. And a lot of that, especially for InfoSec, goes hand in hand with being seen as the department of no. A business wants to launch a new solution or offer a new application or enable a new workflow, and IT security says no, because there's a security consideration, there's a limitation of a security tool. So I think the first step in addressing budgetary constraints is to start to reposition IT and InfoSec as an enabler of the business rather than a cost to the business. And in order to do that, it's important to be able to position these new approaches not just as a replacement or cost reduction from an existing technology, but as an enhancement that will enable mergers and acquisitions to complete more quickly and become productive more rapidly. Cloud migration to go more smoothly, more seamlessly for the user, and to be able to realize those economies of scale with less overhead. Third-party access can be provided seamlessly without the overhead and expense of having to do complex segmentation to restrict what they can get to. And when you provide remote access, you can move away from the need to have these stacks of appliances in these different locations to a cloud service that can scale and expand easily, but also applies the same level of controls in any environment. So I think that one element of that question is philosophical. It's redefining what InfoSec offers to the business. And then the other element of that question is the CFO still wants to know how you're going to save them money. And so looking not only at cost reduction, okay, if we eliminate the VPN gateway, we can also eliminate the infrastructure dependency on load balancing, on those DMZ firewalls, on GSLB, on that denial of service protection for that resource. But you may still need a lot of those components for other things. So another element there is cost avoidance. If you're looking at a larger strategic picture, being able to leverage a tool that you've acquired for one use case to also enable and streamline other use cases allows you to avoid cost on a whole spectrum of scenarios rather than just focusing on what does it cost to operate my VPN stack and what can we save if we take that out. Does that help, do you think?
That's awesome. Yeah, I mean, it makes a lot of sense to be able to show that progress and drive efficiencies where it's not just about hacking and whacking away. So I like it.
Thanks. Great. So when we think about zero trust concept, that concept was really born over a decade ago in that old world of the castle and moat security model. And if you think about how users access resources, again, 20 years ago when I came into the world, I worked for an insurance company. And we assumed that on-premise users accessing internal applications were trusted. So we might have had some levels of internal segmentation, whether that was port-based admission control, whether it was internal firewalls. But in general, it was a pretty open network. And if you take those users off-premise, we bring them in through the VPN, but the whole concept of a virtual private network is you get the same experience you would on-premise. So again, maybe not a lot of security controls. These same on-premise users are also going out to the internet through that outbound stack. And when they go off-net, you still want to protect that traffic. So we were either capturing outbound traffic for remote users through a full tunnel VPN, backhauling it to the data center to go out, or a pack file that would redirect only web traffic. In this original world of access methods, it's really seen as 4 different workflows, and zero trust only addressed 2 of them. On-premise users going to internal applications. The goal was to give the same level of control and visibility you had for off-premise users going to internal applications. But again, as cloud and mobility have caused the enterprise application landscape to evolve, we've really come to realize that this isn't 4 different problem spaces. It's 4 elements of the same problem space. And so we need to extend a consistent user experience. Why should it look any different to me whether I'm accessing SharePoint on-premise or SharePoint in Office 365? Why should I have a different set of controls when I'm accessing an internal database from my house than from the corporate office? And obviously, this has been blown up in a big way by the work from home push that happened as a result of the pandemic. So a lot of organizations have really had to confront the reality that security controls that are designed for a primarily on-campus user base and a secondarily remote user base may need to evolve as well to handle a much more flexible working environment. As we start to think about more users working from anywhere, because even as the pandemic restrictions shift, it'll be, in a lot of cases, difficult or unnecessary to bring everyone back to the office. So we want to enable work from anywhere, not just work from home. And to do that, we need distributed access with centralized policy and visibility, but we also need the granular level of security and control, and we have to do that in a way that doesn't kill our IT group. So if we think about the 5 attributes of a zero trust architecture, there are some areas that can really help to improve the offering that an IT security group offers to the business. Some of them are security related, some of them are experience related. All of them come together to provide this seamless, comprehensive experience. And one of the most important is reducing or eliminating that attack surface. If your applications and your network are not exposed to the internet, if there's no inbound listener to protect, and if your internal applications are only accessible to authorized users, regardless of whether those users are remote or on-premise, then you can really eliminate and limit your threat model in terms of who can touch what and what you need to worry about there. One of the ways to enable that is to assume that the user needs to connect to the application rather than to the network itself. The network is used for transport, and the users are really never on the same network. That is obvious for remote access users, but it can also hold true for on-premise users if you start to apply the zero trust principles across the board. Now, in order to enable this, you clearly need to be able to scale. And one of the elements of that scalability is a multi-tenant cloud architecture that ensures that this service can offer scalability and data privacy similar to what you get with a Salesforce or a Workday, but enabling security rather than application delivery. And one of the underpinnings of that scalability is the ability to inspect all of the content flowing through the network. So you really need a proxy architecture that can allow you to break and inspect encrypted traffic. The majority of malware these days is delivered in encrypted streams. So if you're not doing SSL inspection, there's a huge blind spot in your threat model. Pass-through architectures like next generation firewalls can struggle to keep up with that requirement for break and inspect as the demand grows. But a proxy architecture can allow you to really scale to full visibility. The Secure Access Service Edge model was identified by Gartner as a framework for delivering this kind of security. The ability to push security and policy out to the edge as close to the user as possible to ensure performance and to enable application delivery in as direct a fashion as possible, rather than bringing a user into the cloud at an on-ramp, but then having to pull them out somewhere else in the cloud to a compute node, back to that on-ramp, and then deliver them to the application. It's just reinventing the VPN hairpin. That hairpin is just now in the cloud rather than between your data center and another location. A secure access service edge puts the compute at the edge of the network, so the user enters the cloud, the policy decision and connectivity provisioning is done at the point of entry, and they go directly to whatever they need to touch. So we're moving from the architecture that is data center and network centric, the traditional network security architecture, to a cloud-enabled zero trust architecture that's built for today's world.
So maybe we can take a quick pause here and take a question from the audience. First of all, thank you everyone for submitting your questions. I know Rob and Lisa are eager to answer them. And Lisa, certainly thank you for the initial insight that you've been sharing with us up to this point. So I've got a question from Kathy, and she's talking about a scenario whereby they have a flat network and an open VPN policy. But they don't have any visibility into who's accessing what, from where, etc. And that zero trust seems to be something to take on that is obviously very complicated in that type of environment. So I'd be interested to know what your thoughts are on how companies are tackling that challenge today.
Absolutely. It's a great question. One of my first jobs in InfoSec, I was a security analyst running the firewall VPN gateways for client to gateway and business to business VPNs. And our VPN gateway was an open layer 3 IPsec VPN. If you were on the VPN, you were on the network. And if you had told me at the time that I could create a policy for which users could connect to what applications, I would have told you that if I was being honest, I didn't know which users needed to connect to what applications, and I really didn't know what applications were on the network itself. With a flat network, IT obviously wants to control what gets spun up, but there's nothing really stopping people from running a server under a desk, and I may actually have done that myself in a previous life. So the initial step is visibility. When you're trying to make a transition from this open environment, you're obviously not going to eat that elephant all at once. Using a solution that will allow you to create a connectivity model that enables users to connect to all of the same resources without restriction, but then gives you a readout of what applications are being connected to and by whom. You can gather enough visibility into your application workflows to then start to identify what kind of granular policy you want to develop. So you really want to start to look at, what's my list of discovered applications? And in that list, the first level of triage falls into 3 buckets. Things that you know about that aren't critically important. It's okay to continue to allow open access. Things that you know about that you really want to lock down in a first wave. And what the heck is that? So you can then start tackling, the first problem, we'll put that on the shelf, we'll deal with it later. The second set of resources, you can start to build granular policies for those resources. And in parallel, you can start to investigate just what the third resources are. So, to mangle Donald Rumsfeld, you have your known knowns and your known unknowns. and you really just need to figure out what to do with each. The figuring out process also takes some thought, obviously. When you start to define a granular policy, you can really approach it as who is allowed to get to what, or you can approach it as what needs to be accessed by whom. And in those cases, that translates to you start with a user community and you identify the resources they need to get to. Something simple is generally a third-party relationship where they're a vendor or a supplier or a simple contractor. They're touching your HVAC system or they're touching a particular application that they're managing for you. They don't need access to the rest of the network. So that's a really user-driven space. These users need access to these resources. An alternative approach could be an application migrating to the cloud from the data center. You know you have this application, you know you want to move it. Let's see who's going to be affected when we move it. And so you can start to write a policy based on the resource to say who is allowed to get access to it. And these are not mutually exclusive. Good security policies result from a combination of these two approaches.
Thanks, Lisa. I think that's very insightful. We appreciate your comments there.
Thanks.
Rob, over to you. And back to you.
Okay. So Zscaler has a number of services that enable customers to really start to break down the zero trust problem into manageable chunks. When I started out doing NAC, it was port-based admission control, it was identity-aware firewalls. I was a global NAC specialist for Juniper Networks and then for PulseSecure for about 11 years. And what we found was, what I learned was that you scope a zero trust deployment and then you start to realize the limitations of the technology. So it was very rare to see a zero trust initiative that was 100% complete at the end of the process. It was much more common that you get 80% of the way there or 60% of the way there or 40% of the way there and realize that the rest of it was too difficult or too expensive or too time consuming. So if you want to break it down into manageable chunks, it's a lot easier to approach it as a set of use cases or a set of scenarios. What kind of traffic do you need to protect? What direction does that workflow go? So Zscaler's suite of services on our global cloud platform starts off with our internet access protection. This is our flagship solution, secure web gateway, although it's no longer limited to just web traffic. So we offer cyber protection, data protection, such as data leak prevention and cloud access security broker. And this enables the direct to internet model with local breakouts, SD-WAN initiatives, supports migrations to Office 365. This enables you to protect your user to internet traffic. And again, that's not traditionally considered part of the zero trust space, but it should be, because not only are you protecting your users from the internet, but you're also protecting their communication with trusted data that's in a software as a service application. Once you've got that in place, another obvious area to move on to is private access, the more traditional zero trust approach. And the ability to offer remote access without a VPN, whether that's from a user on-premise connecting to a different data center, a user on or off-premise connecting to an application in the cloud, a user at home connecting to resources all over the place. You can apply zero trust principles across the office, the data center, the branch, the cloud. And you have the ability to handle not only employees and workforce adjacent employees like contractors or consultants, but also third parties and even B2B access. Now, in order to deploy all this, visibility is again critical. And Zscaler is really well positioned to offer that visibility. Our Zscaler client connector sits on the endpoint and handles traffic for those two outbound services, which means that we can see basically everything that user is doing. When I worked at that big health insurance company, my least favorite help desk call as the VPN owner was access to this app is slow over the VPN. Because where do you even start with that? Is their PC underpowered? Is their uplink from their ISP congested? It's almost always the last mile, frankly. Is their backbone congestion? Is the data center that they're connecting to under some kind of load? Is the server that they're trying to reach overwhelmed? You have to walk through each of those steps to figure out where the problem is. It's actually easier to me to troubleshoot, I can't get to this over the VPN, because at least I can see how far the packet goes, where it stops, and who's the culprit. In a cloud and mobility-enabled environment, you still need all of those elements of visibility, and Zscaler can offer them. The Zscaler digital experience solution allows you to get performance scores for the user experience by user, by application they're connecting to, by location that they're connecting from, so you can identify and resolve device and network issues. It's like you get a heat map of every area that the user is touching and how the performance looks across that for an individual user or for your entire organization going to a specific application or an entire backend service. And we're really trying to move out of the user-centric focus. It's critical, and it will always be at our core, but we're recognizing that machine-to-machine and application-to-application is equally necessary to protect with a zero-trust approach. So the ability to offer cloud security posture management, to evaluate your configuration in your cloud provider against regulatory frameworks or security templates is critical. And the ability to segment applications so that when you have one server talking to another, only the authorized applications can actually communicate. You don't have a lot of exposed workflows or potential paths that could be exploited. Across all of these services, we use artificial intelligence and machine learning to make more intelligent decisions on everything from Cloud Sandbox for the outbound traffic to which applications can communicate for which for our secure workload protection. This allows us to create better security, an improved user experience, and enhanced availability. When we think about how this benefits our customers, I have some really good examples here of joint deployments between Zscaler and OBS. So Takeda is a company in the pharmaceutical space, and they have standardized on Zscaler. They were already running the secure web gateway solution before COVID-19 hit, and they had business continuity problems during the pandemic, but they had also had to deal with a large merger that had resulted in a hybrid network architecture, over 300 different firewalls, many different levels of security protection and hygiene and tooling. So their initial attempt to allow those users across that M&A joint was to enable full network access. And they wanted a way to have better control and better visibility of who was connecting where, as well as to simplify that connectivity. So they used the Zscaler Internet Access Service with local internet breakout to allow them to standardize on a single policy and eliminate the need for those hundreds of firewalls for outbound protection. And the ZPA, the Zscaler Private Access deployment, enabled them to scale to the demand of a suddenly fully work from home workforce and to also get better visibility and granularity. So the zero trust approach allowed them to go by application and not over provision access. They could really do true least privilege access. There's a YouTube link here for a video of one of the Takeda executives talking about their experience. And one of the challenges is none of this stuff is easy, to be honest. It's a complex environment. It's a complex set of tools. And to get it right, you really need someone with the expertise to help deploy and configure it. Zscaler obviously offers deployment services and professional services, but we also depend on strong partners like OBS. And in this case, the OBS managed service enabled Takeda to streamline their deployment and to ensure that it was best practices and well configured throughout every step of the way. Another good example of a joint customer success story, this one out of Europe, is DB Schenker. So DB Schenker is a global logistics company, and they moved to a server-free branch model. So they were a cloud-first initiative and software as a service, trying to get away from the data center hosted applications and branch hosted applications. Obviously, again, when COVID-19 hit and all of their users went to work from home, they had to handle that. And in their case, they could not scale their VPN infrastructure to meet the time constraints of the incredible demands that are put on a logistics service every day. So there again, they were using Zscaler Internet Access for secure local breakout and bandwidth control to ensure that critical traffic was prioritized. They were able to test and have ZPA up and running in production in 2.5 weeks. So they were not a consumer of ZPA prior to the pandemic. And they found that they were able to eliminate impact to the company's global operations by rolling out Zscaler private access initially to 8,000 affected users in early regions like China and Southeast Asia, and then following that with a global deployment across their tens of thousands of users. So Marcus Sontheimer, their CIO, wrote a great article on their business continuity plan. And again, that's available if you'd like to hear it in their words.
So Lisa, I think I want to jump in here. I want to ask you a question. So we talked, I think, about two really compelling case studies, really showing the power of Orange and Zscaler and how we can actually, from an agility perspective, handle a lot of clients' new requirements in this COVID phase. I guess the question I have for you is, how did you guys really adjust internally to be able to scale up to traffic to address that surge?
Yeah, that was exciting. So prior to COVID-19, Zscaler was handling about 100 billion transactions a day. And that right there is over 10 times the number of Google searches in a day. So that's a significant traffic load on our cloud to begin with. We are now handling 135 billion transactions a day. So to this point, the COVID-19 traffic has increased our global traffic by a third. What we also found was that new and existing customers deployed hundreds of thousands of new Zscaler private access users. And one of the reasons for that is our user base for Zscaler internet access is much larger. That solution has been in production for almost 11 years now. The ZPA service was introduced about 5 years ago. So obviously it's going to take some time to catch up. And we did a lot of that catching up over the last few months. The ZPA traffic grew 1,600% across the 3 to 4 month period in the middle of the pandemic. We are now in 450 of the Forbes Global 2000. And in order to do that, we really took advantage of our born in the cloud ability to scale. We have our own nodes where Zscaler operates in peering environments that allow us to go also directly to partners like Office 365, et cetera. But we also have expansion capability in the cloud. You don't absorb a 1,600x increase with data center deployments. So I don't want to think about what our AWS bill was, but we were leveraging the same principles of agility, scalability, and elasticity that we offer to our customers. And now, as things are, moving into the next normal, we're finding that we can shift some of that capacity onto our own data centers. We will still continue, obviously, to spin up new environments and to have capacity in the cloud. So we were really tested, and it wasn't 100% easy, but we were able to scale to meet demand.
Wow, it's comforting to know that someone like Zscaler can actually handle those workloads, and that's amazing. 1,600 times, it's unbelievable. So
our operations team is the unsung heroes in this. There were guys across the globe that were working around the clock, and they really, a fire would start somewhere. This dispatcher is overloaded because somebody just dumped 40,000 new users in Germany. What do we have to do to distribute that load? A lot of our automated systems were scaling at a pace that even our existing automation needed to be adjusted. So there were a lot of tweaks made for optimization on the back end by the engineering team. There was an incredible cross-platform lockstep from support, professional services, engineering, QA, operations, product management. The field would come in and say, X company wants to deploy 200,000 users over the next 8 weeks. And that's not a joke. That was for real. And so everybody gets together and says, where are they going to be? What do we need to do to support that? Where do we know that we need to increase capacity? What things do we know we need to keep an eye on? It was epic.
Wow, impressive. Awesome.
Thanks. So what this really has allowed us to do is to offer a service that can simplify, improve user experience, and reduce risk all at the same time. When you think about user productivity, by eliminating a set of backhauling and hairpinning, indirect access, we can ensure that the user gets the fastest path and a consistent, transparent user experience. We can also bring that security closer to the users. Currently, we have over 150 data centers around the world in addition to our cloud scaling capacity. So we deliver a true secure access service edge. From a business risk standpoint, we can protect against today's sophisticated threats such as ransomware and phishing, while also reducing or eliminating the risk of capacity limitations impacting the ability to deliver. And we offer data protection for users as well as for IoT or OT backend servers. We reduce the cost and complexity of this giant enterprise security challenge by enabling organizations to consolidate and eliminate security point solutions and to reduce private WAN costs, especially as they start to migrate to a direct-to-internet model. So Zscaler's goal is really to deliver the agility, security, and experience that the IT and InfoSec teams need to empower a business. And we do that by partnering with solid partners like OBS, who can bring your expertise, your managed services capabilities, and a great amount of background experience to the table. Mark, do we want to maybe see if there are some questions from the audience again?
Yes, Lisa, we do have some questions from the audience. As a matter of fact, Alejandro wanted to ask a question about the fact that we've been talking a lot about controlling application traffic, but they're more concerned about the information that actual traffic carries. I think the question is, how does Zscaler protect that data in that situation?
That's a really good question. That's my background. I'm focused on network security, and it shows in my biases. But data security and data privacy are also equally important. So from a data protection standpoint, our secure web gateway service, the Zscaler Internet Access offering, has sophisticated data leak prevention. So we have the ability, for example, to do exact data match. Rather than just say, we're going to look for everything that has the format of a social security number, we can allow an organization to look for the specific social security numbers of their employees without ever exposing that data to us. So you can do sophisticated protection for data to make sure that it doesn't leave your environment. We also have an interesting acquisition that we made recently, last year actually, a company called Appsulate. And Appsulate brought us a browser isolation capability. The concept of browser isolation is when you have a user driving a web browser that's connecting to a web server, if you can insert a cloud-based container in the middle, then the user actually connects to the cloud container, and a browser in the cloud container makes the actual communication to the backend server. So we can use that in a couple of different ways. Integrating that with our Zscaler Internet Access service allows us to protect the user from malicious websites. You can ensure that if a user connects to a site that has malware, like there was a great news article that users were surfing to Forbes.com and getting infected. Forbes.com. And it turned out it was third-party adware that had malicious JavaScript inserted. So you don't know who you can trust. With browser isolation, any attacks would be captured in the isolated browser. The user just receives a stream of pixels rendering that visibly in their browser. Now let's take that model and flip it around. Now we want to say, let's protect the data in the server from the end user. So that's something that Zscaler is working on as our next integration for browser isolation. We've got it running with Zscaler Internet Access. When we integrate it with Zscaler Private Access, you'll be able to say to a third party, here's the URL to connect to this web application. What'll happen in reality is that third party will connect to an isolated browser. The isolated browser will do the communication. The data stays on the backend server and the isolated browser. You can control downloads. So the user may be able to, for example, connect to a web server, download a piece of data and move it to Box, but never actually have it touch their endpoint. It all happens in that isolated container. Another area that often comes into play when you talk about data is data privacy and the ability to respect, for example, GDPR. We see a ton of sensitive information about our end users, and a lot of that would fall under GDPR. user identity, IP address that they're coming from. So we have the ability for that outbound traffic to obfuscate that user information, and the logs that are stored are tokenized so that general administrators are not exposed to specific identity in that log data. It can only be de-tokenized, de-anonymized as needed. The other thing that allows us to do is possibly a right to be forgotten, where if we've tokenized that user's information and we delete that token, then effectively that information is no longer available. It's as if you encrypt a piece of data and then throw away the encryption key. So there are a number of ways that our service allows us to handle data privacy as well as data confidentiality.
And you actually just answered one of the other audience questions, was around, how do we actually how do you enable privacy and address those concerns while inspecting content? So you hit that right out of the park. That was great.
I may have cheated and snuck a peek at the questions in advance.
So. I think that answers all the questions that we had, Rob, so back to you.
Excellent. All right. So that concludes the session. So before we close, obviously, I want to give a special thank you to Lisa. Excellent presentation. Really appreciate you sharing your insights for us today. Definitely understand more on how we can become more resilient and how transformation and what we've done foundationally up to date will help us drive that resiliency. I also want to thank you, Mark, of course, helping to man all these great questions that we received. Most importantly, though, thank you to everyone who joined today. Appreciate you being part of the session and joining us live. All my best to you all as you navigate towards your resilient future. In the meantime, if you have any other questions, please don't hesitate to reach out to your local Zscaler rep or your OBS rep here. And with that, I'd like to say goodbye. Thanks again for joining us today. Take care.